Okay, now what we're going to do is look at graphing logs and being able to graph a log, because this is a base 2. I can't just simply put it in my calculator. I'm going to take it and rewrite it in exponential form, which is one of the first things that I showed you with this lesson today. So if I were to change this over, then I would have 2 to the y is equal to x. Okay, now I'm going to make a table of values using this. Now when we graphed the exponentials earlier, I substituted 2, 1, 0, negative 1, negative 2 in for my x. That's because the x is what I had in my exponent. But see, this time I've got y as my exponent and my equation is set equal to x. So we actually need to substitute in for y and then find the value of x. I'm going to fill my table in backward of what you're used to doing, but it's just because of the arrangement of where my variables are. So I'm going to have 2, 1, 0, negative 1, negative 2. Okay, so now I substitute 2 in for the y, so the 2 to the second power is going to give me 4. 2 to the first power is 2. 2 to the 0 is 1. 2 to the negative 1 is 1/2. And 2 to the negative 2 is 1/4. Okay, now let's plot these points. Okay, so 4, 2, 2, 1, 1, 0, 1/2 negative 1, and 1/4 negative 2. Now, with the exponentials, I stressed to you about the x-axis being an asymptote. Well, on your log graphs, your y-axis is going to be an asymptote. So as this graph curves and comes down, it's going to come right down along the y-axis, but it's not ever going to go across it. Okay, now we have transformation rules for these graphs. Okay, same rules that we've already had, but I did write them so that you'll see exactly what they look like with a log. Now, when you have the horizontal shift, remember the left or the right, the number that's added or subtracted has to be inside the function. So to be inside a log function, it's going to have to be in the argument. And the way that you know without a doubt that it's in the argument is going to have the parentheses around it, as it does here. Because compare it to this real quick. So you've got a plus c here, you've got a plus c here. But the parentheses is what lets you know that this plus c or minus c is part of the argument, where it's not on these two. Your argument here stops with the x. And then like this is one term, and then this is another term that's separate. Okay, so you'll need to copy those down. Okay, so we're going to graph this one using our transformations. Now you'll notice that this is a base 2. Okay, the log that I graphed for you just a few minutes ago, this one, see, it was a base 2. So I'm going to use this one as my starting point for this. So what we can do, I'm just going to use these 3 points that I have right here. You can use all 5 if you want to, but I'm just going to use these 3 and then use those to do my transformations. Okay, so as far as listing the transformations, first of all, you do have a shift to the left 2. So this being in the parentheses includes that in the argument, so that's going to be left 2. Now, one thing that is confusing sometimes for you is where they put the vertical shift, like the up or the down. You're used to if there's something added or subtracted being here at the end. But, I mean, I could take this, like, and turn it around. Like, instead of this being my first term, you know, I can take it and turn it around and bring it down to the end, and it's still the same thing. So sometimes you'll actually see it in front. So just be aware of that possibility. So looking at this way, you would probably easily recognize that that is to go up 3. Okay. So let me put in the points that I had a while ago. Okay, so going back to that first one, I'm going to use the point 2, 1, 1, 0, and 1/2 negative 1. And I'm going to transform those 3 points. Okay, so first of all, I need to go to the left 2. So taking this point left 2, and now this one left 2, and now this one left 2. And then last, each one of those will need to be shifted up 3. Okay, now let's think about our asymptote. With your log graph, remember your asymptote is your y-axis. So first thing I did was shift left 2. So these 3 points had to go to the left 2. Well, that asymptote has to go to the left 2 also. So if it goes to the left 2, that gives me an asymptote right here. But see, going up 3 doesn't cause that to move. I mean, it's a line that keeps going up and down forever. You shift it up, it's still going up and down forever. So when I connect these points up, I've got to remember just to bring it down, you know, right here along the asymptote, but don't go across it.